So let's look at gravity, shall we? Gravity is strong enough to hold the oceans to a spinning ball, yet weak enough that birds can still fly. Credits to J.M. This is what Isaac Newton said to Robert Hooke. I have not been able to discover the cause of those properties of gravity from phenomena, and I frame no hypothesis. For whatever is not deduced from the phenomena is to be called a hypothesis. And hypotheses, whether metaphysical or physical, whether of occult qualities or mechanical, have no place in experimental philosophy. So basically he's saying this is a philosophy, he cannot make a hypothesis, and so he didn't really believe in what he was saying about gravity. It is an assumption. And we can see again in Wikipedia saying this under an assumption of constant gravitational attraction and so on. It is an assumption, and Newton knew it, and scientists know it. Okay, gravity is an assumption. They want to explain something, and there is a greater deception why they want to make a theory of gravity, although it can be easily explained by density. So imagine this. You look at gravity and say it has a pulling power, and the oceans are tons of water. And yet, even though the earth is spinning, right, it keeps the waters intact, stuck to it. But birds can fly, and we can walk, and we can jump, and so on. Now, if I pull something, I pull a 10-kilo cart with the power, and I pull a 100-kilo cart with the same power. Both carts will be pulled with the same power, okay? So if gravity pulls everything with the same power, how come that it doesn't affect the little bird or you when you're walking? Or gravity, as they think it is very intelligent. He knows when to pull with great power, when to pull with less power. That makes no sense whatsoever. So what you can see here is density, because the density of the water is higher than air, so it goes down on a flat earth. And the density of the bird is, although higher than air, but since he spreads out his wings, he can fly on the air. It captures the air and the winds. Okay. Now look at the football. You try to throw up a football on the earth, it will go down. Why? Even though the air inside the ball has the same density as the air outside of the ball, but the leather covering the ball has higher density, so it will come down, it will fall down. Take that same ball to the water and it will float, because the density inside the ball, the air, is lower density than water. Try to take that same ball down underneath the water and it will float up if you release it. Why? Because again, the air inside the ball is lower than the density of the water, even though that there is this leather covering the ball. The air inside is so lower of density that it comes up. Now take a helium balloon and release it, and it will go up, because the helium inside the balloon has lower density than air. It is simple density mechanics. This is what Newton also said in his letter to Bentley, that one body may act upon another at a distance through a vacuum without meditation of anything else, by and through which their action and force may be conveyed from one another, is to me so great an absurdity that I believe no man who has in philosophic matters a competent faculty of thinking could ever fall into it. In other words, he thinks that if space has no meditation of anything else, as scientists tells us that there is nothing, it's a vacuum. Newton says that two bodies, like the Earth and the Sun, couldn't act upon another, and to think that they can is a great absurdity. So, I mean, you you think that this is true? I mean, how could these two bodies gravitate to one another? I mean, this is a hoax, and you can just read what Newton says. Of course, they don't tell you this at school. He didn't believe himself. Um, he said it was an assumption, and he didn't think that this can work. Okay, so there's no gravity. It is all about density, and that's about it. And density, this kind of thing, what we talked about, and if there's no gravity, then there is no globe. There is no globe, because they want to try to tell you with this theory that that's why the waters and everything can stick to the ball, and you can stick to the earth and not fall off because of gravity. But if there's no gravity, we know if there isn't, it's a hoax. But there is density, then can be a globe, because in a globe you would fall off, right? You would fall off, and so that can't be true. It is a hoax. The earth is flat, there's no gravity. Gravity is a hoax. What we experience is density. And I'm going to link this article in the description of this video.
Okay, I want to show the difference between density and gravity. Density is the ratio of mass over volume of an object. Basically, it tells you how much stuff you have in a given space. Gravity is a force that acts between masses to attract them. For example, the mass of the Earth and the mass of this guy, which has 3 .44 caliber bullets in it, if you can't tell. Now, a clever guy, I'm going to weigh this also to show you. A clever guy by the name of Archimedes discovered, and this is, notice the Archimedes principle now, that if you have an object with a certain mass, and it says 56.63, I'm going to round that up to 57. So let's pretend this is 57 grams. That's approximately equal to 57 milliliters of water. So that's the part here. And I'm just going to demonstrate Archimedes' principle, because trying to describe it in words, I get all tongue-tied. This will displace 57, did I say? Yeah, just about 57 milliliters of water, because water has a density of about 1 gram per milliliter. So let's carefully put this in. Have to be careful because I don't want it to sink. There we go. And here we can see it's gone over 40 on the market. All right. Hopefully that marking is nice and visible. So it's just raised the water by 57 milliliters. Let's take it out and shake off a few drops. I have a graduated cylinder here where I've measured out 57 milliliters of water. And let's add it to the beaker. And look at what we have. They add up. Now, Thrive and Survive was doing some weird thing about air pressure being responsible for rivers flowing downhill rather than uphill. And a convoluted explanation, and I was getting lost about it. And Globebusters on Sunday, they were talking about what would be an interesting experiment involving water leveling. Now, they were under the impression that because the Earth curves, if you filled a hose with water and simply had one end far away from the other end, that the one end would empty out when you opened up the hoses. But in reality, what's going to happen is their water will level to the same distance from the center of the Earth. That is what that's what they mean by water level or sea level. And water leveling has been used at least since the construction of the pyramids. Now, Mr. Thrive and Survive was going on about air pressure. He's saying the pressure of the air is pushing down on water. Well, that's true, but it doesn't mean it's going to make them flow uphill unless there's other higher pressure areas to push down and low pressure areas to allow the water to flow to. For example, during a hurricane or tropical depression, for example. Anyway, I'm going to show a new water level by putting my float back in, which takes it up another 52 milliliters. I'm going to mark it. Now, I didn't degas this water. Even though this vacuum pump I'm about to use, and it's going to make a lot of noise, is not powerful enough to make water boil, sad face, it can degas water. So there's going to be bubbles forming in there, but don't worry about it. That shouldn't affect the experiment in any way. Let's get a good seal. Water level is the same. I'm not worrying about the current barometric pressure, but I am worried about being able to read the dial. And I've got bad contrast here, too much backlight. So how do I deal with that very quickly? Let's put something dark behind there. And don't worry, this is not a threat of any kind. I just want you to be able to see that the gauge moves down. Actually, I've got two of these, so let's block off even more light. I didn't anticipate this. It's not part of the experiment. I'm just trying to get the camera exposure right. Alright, now the gauge is visible. Good. So we've got the water level sitting with an object whose mass is displacing, well, it's displacing, what did I say, 57 milligrams of water. Actually, you know what I can do with this thing? I can do something else with this thing. Before I even run the, I just now thought of this. Before I even run I'm going to sink it. Now this will raise the water a little. Will this raise the water some? I actually don't know. I mean, there's a bit of volume up here, right? And there's airspace in here. See, it's dry inside. So let's just deliberately sink this thing. Okay. It's actually gone down. So I've sunk it. And it's showing very close to its original displacement. That is from where I added the water. And if I pour the water out again, hopefully not, I spilled some, so it's not very precise. We're back to where we had added the 57 milliliters of water. I'm going to let it float this time, because really what I want to do is show that nothing should happen just because I pump out a bunch of air. The red scale is in kilopascals, the black scale is in inches of mercury. So let's get her going. Oh, this vibrated out. Oh dear. No, don't tell me I'm broken. Murphy, how dare you create that law? Okay. It's only gotten to 88 kilopascals of vacuum. And it doesn't seem to want to go anymore, so I'm going to let it sit at that. It's not actually important. You'll notice bubbles have formed from outgassing. Watch them disappear. If you can see them, hopefully you can see them. I'm going to disconnect that. We get a bit of condensation. Anyway, the whole time, the water level has not been changing. Now, my normal method of getting this off has been to hook it up to the Other hose, will you go with no load? I think I burned, oh wait, I unplugged it. We run with no load. Okay. I'm going to just pop that guy off. I do it that way because it really gets wedged onto the gasket. So when I take it out, we go back to the original mass of the water. That is, the original approximately 350 milliliters plus the 72 that I added that matched the roughly 72 grams that this takes up. So I believe there, by using Archimedes' principle, showing the difference between density and gravity. I mean, see, this still wants to go down. Air didn't have anything to do with it. Water didn't have anything to do with it. It's nothing about cherries floating on top of stratified liquids of different densities that don't mix together. And really, the weight is just the acceleration of Earth's gravity, which is 9.81 meters per second, times the mass of this in kilograms, which would give you newtons. The scale just turned it back into grams because it knows the acceleration of gravity. It's built into how digital scales work. So hopefully I've made a reasonably clear experimental demonstration showing difference between density, gravity, and throwing into the mix Archimedes' principle. Any questions or comments? Be sure to just post them below. Signing out.
So let's look at gravity, shall we? Gravity is strong enough to hold the oceans to a spinning ball, yet weak enough that birds can still fly. Credits to J.M. This is what Isaac Newton said to Robert Hooke. I have not been able to discover the cause of those properties of gravity from phenomena, and I frame no hypothesis. For whatever is not deduced from the phenomena is to be called a hypothesis. And hypothesis, whether metaphysical or physical, whether of occult qualities or mechanical, have no place in experimental matter, is higher than air, so it goes down on a flat earth. And the density of the bird is, although higher than air, but since he spreads out his wings, he can fly on the air. It captures the air and the winds. Okay. Now look at the football. You try to throw up a football on the earth, it will go down. Why? Even though the air inside the ball has the same density, and I pull 100-kilo cart with the same power, both carts will be pulled with the same power. Okay. So if gravity pulls everything with the same power, how come that it doesn't affect that little bird or you when you're walking? Or gravity, as they think it is very intelligent. He knows when to pull with great power, when to pull with less power. That makes no sense whatsoever. So what you can see here is density, because the density of the water philosophy. So basically he's saying this is a philosophy, he cannot make a hypothesis, and so he didn't truly believe in what he was saying about gravity. It is an assumption, and we can see again in Wikipedia saying this under an assumption of constant gravitational attraction and so on. It is an assumption, and Newton knew it, and scientists know it. Okay, gravity is an assumption. They want to explain something, And there is a greater deception why they want to make a theory of gravity, although it can be easily explained by density. So imagine this. You look at gravity and say it has a pulling power, and the oceans are tons of water. And yet, even though the Earth is spinning, right, it keeps the waters intact, stuck to it. But birds can fly, and we can walk, and we can jump, and so on. Now, if I pull something, I pull a 10-kilo cart with a power,